This conference will now be recorded.
Welcome to Live Talk with Dr. B. Hill. Today we are going to discuss those graphs that we were talking about yesterday with Dr. Doug Smith. So, Dr. B.
Thank you so much, Chrissy. I really appreciate it. And we have Dr. Smith here today. Hi, Dr. Smith.
Good afternoon, Dr. B.
We were having a really good talk yesterday regarding the graphs that you had, and I'd like to go back over briefly and then go deeper into them if that's possible.
Well, Dr. B, if you want to, let's start with if I'm not mistaken, the first graph we showed yesterday was the first image that we showed yesterday was this one right here of the DNA, and this seems to be the image that uh, people are able to find some level of understanding. Um, what you're looking at there, Dr. B, is this is how geneticists talk to each other. It's almost like it's a separate language, and you just have to kind of understand their language. But what you're looking at there is a representation of one gene. The name of this gene is called the OPRM1 gene. OP stands for opioid, R stands for receptor, and M1 stands for mu1. So this is the primary opioid receptor. This is the gene that makes the primary opioid receptor. Um, all the information that makes and runs our body is stored in our DNA, and different genes have different functions. And the function of this gene is to make a receptor that will bind with the opioids, an opioid receptor. This is an old gene. This is an ancient gene. You can go back hundreds of millions of years and begin to see the emergence of this gene. And since it is such an old and primitive gene, this opioid receptor is involved in some of the most basic functions of life. Okay, this receptor is involved in some of the most basic functions of life. People think of the opioid receptor as only being involved in pain. Okay, and it is involved in pain, but pain itself had a purpose. The purpose of pain was to get the organism to do something. Okay, there's a bear chewing on my arm. It hurts. Run away. So part of the purpose of pain was to trigger the fight or flight uh, reaction that's so ubiquitous to life itself. But this is the OPRM1 gene, and what we're looking at here are the actual locations where the poisoning is located. Everywhere where you see a blue column and a red column. The blue column are opioid naive individuals, people who've never really taken any opioids. And the red columns are opioid dependent people, people who, when they stop taking the opioids, they get sick. Now, if what was going on here was a mental health diagnosis, the DNA wouldn't be involved. DNA is not involved in a mental health diagnosis. If what was going on here was a mental health diagnosis, these two columns would be equal. The blue and the red would be the same height. So the fact that there is such a profound difference at so many locations between the blue column and the red column, that just shatters the myth, the fairy tale, that what these people are experiencing is a brain disease called opioid addiction. B, does that make sense to you? Dr. B, does that make sense?
Yes, it does. But in the many, many, many people that I have talked to, every single one of them said, I don't take an opioid. I've never taken an opioid for pleasure. I've taken it so that I wouldn't be very sick. So I don't understand why that's the pleasure center of the brain is what is seeking this opioid.
Well, Dr. B, what you're talking about there is the foundation, the fundamentals of the brain disease uh, hypothesis, the brain disease model of addiction, and maybe we should put the emphasis on the word model. Okay, the brain disease model. It's really not even much of a hypothesis. Okay, science isn't so much based on models. Science is based on a hypothesis. You create a hypothesis, you make predictions, and those predictions are either true or false. And if the predictions are true, that reinforces your theory. If the predictions are not true, that does not reinforce your theory. But they really don't have any hypothesis, any predictions coming out of this brain disease model prediction. It's really not something that's very scientific. It's really more the opinion of a bunch of people who've decided that their opinion carries more merit than the science itself. Whereas what you're looking at on that screen right there, Dr. B, that's science itself. Okay, now, interestingly enough, the Smith hypothesis, we predicted that this is exactly what you would see. Okay, the brain disease model of addiction has no prediction about the DNA. It doesn't explain any of this. Okay, but the Smith hypothesis, we predicted that you would see this DNA damage by the opioids, particularly in the promoter region of the OPRM1 gene. And Dr. B, when you see this much damage, this spread out across a gene, it's unrealistic to believe that that gene is going to function normally, because everywhere that the red column is bigger than the blue column, that's an area of the gene that possibly experienced what's called gene silencing. That area of the gene got turned off. And if you're turning off this many areas of the gene, this haphazardly, this randomly, there's going to be some impact on that opioid receptor that is created from the damaged DNA. It is inconceivable to believe that opioid receptor is going to be normal when you're looking at this level of genetic damage. Does that make sense?
Yes, and it's my understanding though that they did a test 32, 33 years ago. Very, very crude test by putting glass pieces in mice brains and injecting them with dopamine or whatever they injected them with. It doesn't really matter, but to me, if you have a study like that, and then there are further studies that come out that are using more modern techniques, doesn't that take your study that you've done? Aren't you supposed to update your study or change it
What
or?
you're talking about there, Dr. B, is the older study from 1988 done in Italy is the Dai Chiari study. The two more modern studies that were done using a much more advanced technology were the Daglish and Watson studies of 2009 and 2014. And B, what you're talking about there is the fact that the type science that we do is known as a form of science called Popperian science, Popperian. Popperian science is named after Karl Popper. Karl Popper was really more of a philosopher, I would say, than a scientist. But he was Austrian, and during the rise of the Nazis, fled Austria to England, where he lived out his years. And Karl Popper not only advanced the concepts of Popperian science, but he particularly advanced a concept called the falsification principle. The falsification principle, as put forth by Karl Popper, is along the lines of common sense. The falsification principle says that it's very difficult in science to prove that something is true. It's hard to prove something true. You're much more likely to prove that it's not true. For instance, if I had the hypothesis that all birds can fly, and Dr. B, you showed me a penguin and an ostrich and said, hey, here are two birds that can't fly, my theory that all birds can fly has been disproven. And once something has been disproven, it's disproven. And if you're going to be compatible with modern science, if you're going to be compatible with Popperian science, you can't run around and say things that are and claim they're true if they've been disproven. And so with the Dai Chiari study from 1988, Dai Chiari drilled little holes in the skulls of the mice and put in little glass tubes and glued them in place and hope they were in the right location, hope they stayed in the right location, and then gave the mice different substances to look to see if there was a surge in dopamine in the brain, and supposedly Daciari saw a surge in brain dopamine with amphetamines, with nicotine, uh, with cocaine. I believe it was cocaine, and then supposedly with morphine. However, the morphine study has never been replicated. Okay, it's never been replicated, and even if there was a surge in the Daciari study, it's a very small one, and that's never been replicated. However, it's been disproven. This is where both Daglish and Watson in 2009 and 2014 got volunteers from the local methadone clinic and brought them into the laboratory and gave them opioids, and using the very advanced and sophisticated technique of the PET scan, positron emission tomography. Don't get caught up in the science. Using a vastly superior technology, demonstrated there was no surge in dopamine at all when humans were given the opioid. So the Daciari study was done with mice, not humans. Daglish and Watson was done with humans. The Daciari study was done with a markedly inferior and almost worthless technique called microdialysis, which is no longer used, whereas Daglish and Watson used the much more modern and accurate PET scans, positron emission tomography. They're apples and oranges. You can't even compare really the two studies, the modern studies being so vastly superior. However, you still have everybody in the mental health community, the psychiatrists, the addiction specialists, they're all still running around saying opioids are addictive because they cause a surge in brain dopamine when the opioids are taken, despite the fact that science has proven otherwise. This flies in the face of the falsification principle. This is not adhering to the ways of science. It's just wrong. But since everybody, runs around and says it, if you say something enough times, it must be true. And here we are. We've done DNA studies. We've done catecholamine studies. We've done some hard science, and it is extremely difficult for us to break through the ice that is created by all these voices banding together, going, "Oh, opioids are addictive." Does that make sense, Dr. B?
Yes, it makes a lot of sense. And I mean, after, I guess, them saying it for 33 years, the same thing over and over again, why wouldn't you believe them? And when a new study has come out, why wouldn't they just stand up and say, hey, there's new evidence out there?
Dr. B, I don't think they're going to say that until there have been a series of lawsuits.
Well, then the lawsuits must begin, because this is wrong. There's too many people that have died. Too many people that have died.
I think it's going to take some of the people who have had their DNA test done to go back to the psychiatrist and file a lawsuit for wrongful diagnosis. That's what I think it's going to take, because otherwise they don't get it. They don't see it. Something is going to have to.
Okay, for 33 years, though, this is my problem, okay? For 33 years, they've been treating the patient the same way for a brain problem. Yet the deaths continue, the statistics stay high. I don't understand how they're being successful using the diagnosis that they're using.
I'll take it a
Things
step.
aren't changing.
Let's take it a step further. If the brain disease model of addiction is a valid theory, then from that theory, at least in theory, there should be predictions, and from those predictions should come some type of advancement in treatment. The very fact that this is as decades old, and it has never put forth a valid treatment option, speaks volumes. Now, we're only talking about the opioids. We're not talking about cocaine, alcohol, amphetamines, anything else. Our discussion is purely limited to the opioids. For all we know, the brain disease model of addiction is perfectly accurate for amphetamines and cocaine. That's not our field of expertise. We don't know. We can't comment on that. But what we do know is, according to the brain disease model of addiction, when you, at least according to Dr. Nora Volkow in her statement, we can jump ahead to that slide with Dr. Volkow. According to Dr. Volkow's statement, all drugs of addiction cause a surge in brain dopamine in the reward centers of the brain. Okay,
That's
problem
like
is,
all birds can fly. Isn't
right
that the same as all birds can fly?
now, you don't really see it written very often, but there's a rumbling that, oh, well, you didn't see the surge in dopamine because these people were on methadone, and the methadone has suppressed the surge in dopamine. That's why you didn't see it. Well, then, if that's true, do some studies to prove that. Take some people not on methadone. Okay, you've got to rely on science. You can't just be giving out your opinion, because relying on the opinion of the experts has resulted in millions of deaths. Chrissy, if we can, let's jump forward to the next slide when you get a moment.
Well, you did the same test on people who never took an opioid in their life and the people who have had taken an opioid. So you've tested both sides.
You're talking about the DNA test that we did.
Yes.
That's exactly what we did. We compared the DNA of the opioid naive, and we compared it to the DNA of the opioid dependent, people who get sick when they stop taking the opioids, and we found large amounts of a disease process, poisoning called methylation. We found it all up and down the OPRM1 gene in the opioid dependent as opposed to the opioid naive. We were not surprised by that. Okay, we saw in 2020 with the Sandoval Sierra study. Sandoval Sierra took opioid naive volunteers at the local dental clinic, took their DNA before, during, and after a very short course of opioids. And what Sandoval Sierra revealed in the 2020 study was that even after a few doses, you could see the poisoning. Even after a few doses of the opioids, you could see the methylation in the DNA of the opioid user. This was a very powerful study, and this study is going to be devastating to the opioid manufacturers and distributors in our class action lawsuit, because what this study shows is what's known in science as causation. The opioids caused the damage. Okay, because, I mean, frankly, you could argue that, oh, the opioid naive and the opioid dependent had DNA that were different from birth, and this is what made people susceptible to the opioids. So until you get these causation studies, there's always a little question. But in 2020, what Sandoval Sierra did was went to the local dental clinic, got volunteers who were opioid naive. They hadn't really ever taken opioids in their life, and showed that after just a few doses of hydrocodone or oxycodone, whatever the person was taking, after just a few doses, you could see the poisoning in the DNA. Now, clearly, common sense will tell you there's some threshold of methylation that has to be reached before the damage manifests as symptoms. So when people are first taking the opioids, the damage is accumulating, but the damage is not presenting as symptoms. After some unknown threshold of damage, that's when people show symptoms. In other words, when they stop taking the opioids, they become very sick. Now, Dr. B, you've got something interesting there in front of you, and there on the far left, in yellow, are the abnormal catecholamine levels, the abnormal adrenaline levels. We were the first people in the history of the world to ever do a study where we got volunteers to allow themselves to go into opioid withdrawal, and we drew their blood for the adrenalines, the catecholamines. This study should have been done back in the 1990s. This study should have been done back in the 1990s, but it wasn't done. Why? Because the brain disease model of addiction sucked up all the oxygen in the room and sucked up all the funding for research. NIH gave NIDA control of the research dollars in 1992, and that ended all research into what was a very interesting and promising avenue of research, which was that the opioids cause a damage within the autonomic nervous system, and part of that damage is seen as a abnormality in the adrenalines, catecholamines. But there again, it's just further indicative of the damage that these psychiatrists, these addiction specialists, have done with their non-scientific brain disease model of addiction. It's not science, but they're using it as if it is science. And because it's not science, a lot of harm and a lot of death has occurred.
I noticed there that the opioid craving scale and the autonomic craving scale there
The opioid
is,
scale is a neurotoxicity scale.
oh, excuse me, I'm sorry, sir.
Just to
I noticed how high their craving is, and I notice how bad their symptoms are.
Our theory is that when a person becomes methylated to some unknown threshold, to some certain point, after they've taken enough opioids, when they attempt to stop taking the opioids, when they attempt opioid abstinence, what's actually happening is the damaged receptor, the receptor that's the product of this damaged DNA, the abnormal receptor, is no longer able to function normally. And since evidently part of the function of the opioid receptor is to maintain balance and control within the part of the nervous system that oversees the organs, it is our belief, it is our theory that the individual loses control of the organs because they lose control of the nerves that are controlling the organs. They're not necessarily losing control of the organ, they lose control of the nerve that controls the organ.
Controls it.
And that this state of loss of control of this part of the nervous system is not something that can be endured by humans. It's unendurable. It's horrendous. It's horrid. It's horrible. They can't stand it. And they learn very quickly the only way out of this horrendous situation is to take an opioid, which for most people means going to the street and buying an illegal opioid, what more and more is now fentanyl, risking death from the fentanyl. But it is this abnormality within the nervous system that is driving the opioid craving. And so what we did was we built a opioid craving scale, we built a neurotoxicity scale, and we showed that when the neurotoxicity is sky high, the opioid craving is sky high. And then we gave people one dose of buprenorphine, the neurotoxicity dropped to almost nothing, and the opioid craving dropped to almost nothing. We have proven how to get people out of this opioid crisis, and we're in the process now of working with the FDA on trying to make some progress here.
I also noticed that the level 4 is the highest level, and there are tons of level 4 in there.
In the original scale, we used a 4. We increased it a little bit to the 5 because there were so many 4s. But yes, and what that means is these people are suffering greatly. And when they suffer greatly, they crave an opioid in a manner that they cannot resist. And no amount of counseling, no amount of inpatient therapy, no amount of anything that the psychiatrist and the addiction specialist can do cognitively with these people is going to have any impact as long as they're in this state of a neurotoxicity. That's what opioid withdrawal is. It's a state of neurotoxicity. It is a loss of control of the nerves that control the organs. The organs themselves are fine. The problem is in the nerve that controls the organ, and the reason we believe that is happening is because within those nerves is now an abnormal opioid receptor, And we believe the reason you now have an abnormal opioid receptor is because of the genetic damage that we can now see and measure within the DNA. And this is why we are filing the class action lawsuit.
You know, I find it very interesting that that everybody that I talk to says that they thought they were going to die when they were going through whatever they want to call it, withdrawal. And yet they've been told that withdrawal will never hurt them. Yet I know that people do die when they go through withdrawal.
We've got a couple of recordings off of the internet of people, psychiatrists, who are saying opioid withdrawal is not dangerous. Chrissy, I don't know if those have been sent to you, and if they have, I'm pretty sure we haven't tried to play them live. I tell you what, we only got a couple of minutes left here. I will get those recordings over to Chrissy, and
Okay.
we'll give it a whirl to see if we can play them live for people to hear. And most of the people that we work with, you're right, they've been told that opioid withdrawal won't kill you, but judging by these levels of adrenaline that you see on the screen right there, the ones that are in yellow, any one of those levels is enough to kill a person. So the concept that you can't die from opioid withdrawal is a fallacy that has turned out to do great damage in this country.
You know, there's so much more that I'd like to talk about. Like, you can't tell me that the pharmaceutical company doesn't know that their drug is defective.
Well, we got to be careful on what they know, what they don't know, and for the purposes of our class action lawsuit, we just got to say with the facts. It doesn't matter what they knew. It doesn't matter what they didn't know. Okay, what matters is what they should have known.
Well,
And
you tell me then, if they don't know, why did they come out with an antidote?
well, buprenorphine wasn't really designed as an antidote. It was actually originally designed as a pain medication, and some of the early studies in France found it as a successful treatment for opioid craving. So I don't think there was a one-to-one relationship there. However, when it comes to the class action lawsuit, what matters is what they should have known, which means what matters is what science had been done. And we see the emergence of science linking the opioids and DNA methylation. We see that coming out in 2009, 2011, 2014, 2018, 2020. And we see evidence of the abnormalities within the autonomic nervous system all the way back to 1963 with the gun study. 1963, 1967, 1990. There is a plethora of historic scientific literature supporting both the association with the opioids and the methylation and the association of the opioids with the neurotoxicity. They don't have a leg to stand on.
Wow. And I know though that the deaths from cardiac have gone up. Oh, I think that's Chrissy, and I think we're finished. Thank you very much, Dr. Smith. I really appreciate the conversation.
Thank you so much for joining in with Dr. B at Live Talk every Monday through Thursday, 12:30 to 1. Thank you so much for joining us today. Have a blessed one.